There is a question so ancient and so unsettling that entire civilizations have built their belief systems around it, not because the answer is unknowable, but because the answer, when you trace it through the cold, precise logic of physics, turns out to be far stranger and far more magnificent than any story ever told about it. The question is this: where were you before you were born? Most people assume the answer is simple. They were nowhere. They did not exist. And then, at some moment inside a hospital room, existence switched on like a light. But here is what makes that assumption so profoundly wrong. It is not just philosophically incomplete. It is physically impossible. And to understand why, we need to go all the way back to the most fundamental law that governs every single atom in this universe. A law so ironclad, so mathematically airtight, that not a single observation in the history of science has ever found an exception to it. That law is conservation. Matter and energy cannot be created. They cannot be destroyed. They can only be rearranged. Think carefully about what that actually means. It means that the universe is, in a very precise sense, a sealed container. Imagine an enormous box. Inside that box are roughly 10 to the power of 80 atoms, the total count of baryonic matter in the observable universe. That box was sealed approximately 13.8 billion years ago. And here is the critical point. Not a single atom has been added to that box since, not one. And not a single atom has been removed. Every atom that exists today has existed since the very early moments after the Big Bang. They have been shuffled, rearranged, assembled into breathtaking configurations, and disassembled again. But they have never been created from nothing, and they have never been annihilated into nothing. This is not a poetic idea. This is one of the most rigorously tested principles in all of science. It is encoded in the mathematics of Noether's theorem, which proves that because the laws of physics are symmetric in time, meaning they work the same way yesterday as they do today, there must be a conserved quantity. That quantity is energy. And since mass is simply a condensed form of energy, as Einstein showed us with the most famous equation in human history, mass is conserved too. The atoms in your body today have been part of this universe since the universe was barely a few minutes old. They were here long before Earth existed, long before the sun ignited, and they will be here long after both have gone quiet. So let us now trace where those atoms actually came from, because this is where the physics becomes almost unbelievably dramatic. In the first few minutes after the Big Bang, the universe was a ferociously hot, dense plasma of quarks and gluons. As it expanded and cooled, those quarks bound together into protons and neutrons. And then, in a process called Big Bang nucleosynthesis, those protons and neutrons fused together to form the simplest atomic nuclei. Hydrogen, which is just a single proton, helium, which is 2 protons and 2 neutrons, and tiny traces of lithium. That was it. The entire periodic table of the early universe was 3 elements, a universe of hydrogen and helium and almost nothing else. But here is the question that changes everything. You are not made of hydrogen and helium. Your body contains carbon, oxygen, nitrogen, phosphorus, iron, calcium, and dozens of other heavy elements. Where did all of those come from? The Big Bang did not make them. So how did they get here? The answer is stars, and specifically, the deaths of stars. Roughly 200 million years after the Big Bang, the universe had cooled enough and gravity had pulled the primordial hydrogen into dense enough clouds that fusion ignited at the centers of those clouds. The first stars were born. And inside those stars, nuclear fusion began doing something that the Big Bang never accomplished. It began forging heavier elements. In the core of a star like our sun, hydrogen nuclei are fused together under enormous pressure to form helium nuclei. This is the process that produces the sun's energy. But in stars much larger than our sun, the story does not end there. As a massive star burns through its hydrogen, gravity compresses the core further, the temperature climbs higher, and a new round of fusion begins. Helium nuclei are fused together to form carbon and oxygen. Then carbon fuses to form neon and magnesium. Then neon fuses to produce oxygen and magnesium. Then oxygen fuses to create silicon and sulfur. Each stage burns faster and faster, the star consuming its fuel in shorter and shorter intervals until the core fills with iron. Iron is where everything stops. Iron has the most tightly bound nucleus in all of nature. Fusing iron does not release energy, it consumes it. So when an iron core builds up in the center of a massive star, the fusion engine shuts down. In less than a second, the iron core collapses under gravity, reaching densities so extreme that protons and electrons are forced together into neutrons. The collapse bounces back in a shock wave so powerful it tears the entire outer shell of the star apart in an explosion called a supernova. For a brief moment, a single supernova can outshine an entire galaxy of hundreds of billions of stars, and in that catastrophic explosion, something extraordinary happens. The shock wave creates conditions hot and energetic enough to produce nuclear reactions that no normal stellar core ever could. Elements heavier than iron, including nickel, copper, zinc, gold, platinum, and uranium, are forged in seconds inside the fury of a dying star. And then they are blasted outward into space. This process is called stellar nucleosynthesis, and it is not a theory. It is confirmed by the spectra of supernovae, by the chemical abundances we measure in ancient stars, by the ratios of isotopes we find locked inside meteorites that fell to Earth billions of years ago. The oxygen you are breathing right now was forged inside a star that died before our solar system existed. The carbon in every cell of your body was fused together in a stellar core perhaps 5 billion years ago. The iron carrying oxygen through your blood right now was scattered across a cloud of interstellar gas by a supernova explosion that happened before Earth was even a thought in gravity's mind. You are not made of new material. You are assembled from the oldest material in the universe. Now let us think about what happened after those atoms were scattered into space, because this is where your personal history, your actual physical history begins. After a supernova scatters its enriched material into the surrounding interstellar medium, those atoms drift through space as part of a molecular cloud, a vast, cold, sparse collection of gas and dust. Over millions of years, gravity pulls regions of that cloud together, density increases, temperature rises, new stars ignite, and surrounding those stars, the leftover material, a flat disk of gas and dust, begins to clump together through a process called accretion. Rocks collide and stick. Rocks grow into boulders. Boulders become planetesimals. Planetesimals merge into planets. This is how Earth formed approximately 4.5 billion years ago, and the atoms that now make up your body were part of that process from the very beginning. Some of those atoms were locked deep inside the molten mantle. Some were embedded in rocks that later became mountains. Some drifted in the atmosphere as carbon dioxide. Some were carried to Earth by comets and asteroids that bombarded the young planet in its early history, bringing with them complex organic molecules, the chemical building blocks of biology. For billions of years, those atoms cycled through the geological processes of the planet. They were subducted into the mantle and erupted back out through volcanoes. They were dissolved in oceans, incorporated into the first single-celled organisms, released back into the atmosphere, rained down into the sea again. They moved through food chains as life grew more complex. A carbon atom that is now sitting inside a neuron in your prefrontal cortex may have been part of a dinosaur's bone, then dissolved into soil, then absorbed by a tree, then exhaled as carbon dioxide, then dissolved into the ocean, then incorporated into a fish, then eaten by an early human, then exhaled, then absorbed by a plant, then eaten by an animal. Your ancestors hunted, then metabolized, then exhaled again, and then eventually, through a long chain of biological processes, incorporated into the food that your mother ate before you were born. The atoms did not wait passively for you. They were constantly in motion, constantly being rearranged, constantly cycling through other configurations, other structures, other temporary patterns. What happened at the moment of your conception was not the creation of something new. It was the beginning of a new organizational pattern imposed on ancient, well-traveled material. This is where one of physics's most powerful analogies becomes useful. Think about a wave rolling across the surface of the ocean. When you watch that wave from the shore, it is easy to think of it as a thing moving toward you, a distinct object traveling through space. But look more carefully and you realize that the wave is not made of a fixed parcel of water moving across the ocean. The water molecules in the wave are barely moving at all. They are mostly just moving up and down in place. What is traveling across the ocean is not water. It is a pattern, a temporary organization of energy moving through a medium. The wave crashes on the shore and appears to vanish, but the water does not vanish. It simply becomes part of the flat ocean again, ready to be organized into a new wave by the next swell of energy. The wave was never a thing. It was always a pattern. Now consider your body in exactly the same way. Every atom in your physical frame is borrowed from the universe for a temporary period. The atoms in your bones today are not the same atoms that were in your bones 7 years ago. Calcium is continuously deposited and reabsorbed. Carbon cycles in and out of your tissues. Water molecules flow through you by the trillions every day. You are not a fixed collection of particles. You are a wave. You are a temporary, highly organized pattern of energy imposed on a substrate of ancient atoms that have existed for billions of years and will continue to exist for billions more. Before you were born, the atoms that would eventually become you were not hovering in a void waiting for an assignment. They were doing what atoms have always done. They were being part of other patterns. They were in soil, in rivers, in plants, in other animals, in the atmosphere. They were spread across continents and dissolved in oceans. In a very physical, very literal sense, you were not nowhere before you were born. You were everywhere. You were scattered. And the physics gets even more precise when we descend below the level of atoms to the level of quantum fields. Modern quantum field theory tells us that what we call a particle, an electron, a quark, a photon, is not a tiny solid ball of stuff. It is a localized excitation of an underlying quantum field. Think of a quantum field as an invisible fabric stretched across all of space. An electron is not a thing sitting in the fabric. An electron is a vibration of the fabric, a ripple in the electron field that exists everywhere simultaneously. What we call matter is simply regions where these fields are vibrating in a particular way, where the energy of the field is concentrated into a stable pattern that interacts with other patterns in predictable ways. Your body, from this perspective, is a breathtakingly complex arrangement of field excitations. Trillions of localized patterns in the electron field, the quark fields, the electromagnetic field, all interacting with each other through the fundamental forces, maintaining a coherent, self-referencing, self-replicating structure that we call a living organism. Before you were born, those field excitations existed in other configurations. The fields themselves never stopped vibrating. Energy never disappeared. The electrons that are now part of your neurons were, before your birth, part of other atoms, organized into other patterns elsewhere in the universe. The quarks inside the protons in your DNA were bound inside other atoms in other molecules, doing other things for billions of years before the biological processes that assembled your body recruited them into their current configuration. There is a deeper layer still. Quantum mechanics tells us that the universe conserves not just energy and matter, but information. This is one of the most controversial and fascinating ideas in modern theoretical physics, and it sits at the intersection of quantum mechanics and general relativity in a way that we do not yet fully understand. But the principle, supported by decades of theoretical work, is this. The quantum state that describes a physical system cannot simply vanish. Even if a star collapses into a black hole and that black hole eventually evaporates through Hawking radiation, the information about what fell in, encoded in the quantum states of every particle, must somehow be preserved in the outgoing radiation. What this means is that the universe keeps an account of everything. Every quantum state that has ever existed is, in principle, a transformation of a prior quantum state. Nothing is truly created from nothing. Nothing is truly destroyed into nothing. Every pattern of matter and energy that has ever organized itself in this universe is a transformation of what came before. You were part of a supernova before you were part of a molecular cloud. You were part of a molecular cloud before you were part of a planet. You were part of a planet before you were part of a geological cycle. You were part of a geological cycle before you were part of a food chain. You were part of a food chain before you were part of a single cell. And you were part of a single cell before you were a recognizable organism with a face and a heartbeat and a name. At every stage, the material that constitutes you was doing something. It was participating in some process, being part of some pattern, subject to the same physical laws that govern every atom in this cosmos. The concept of a beginning of your physical existence is a story we tell, a useful narrative anchored to a particular level of organization, the level at which a coherent biological organism first appeared. But the atoms themselves have no beginning in any meaningful sense. They trace their lineage back to the first minutes of the universe, and before that, in a sense that stretches our mathematics to its current limits, to whatever gave rise to the Big Bang itself. The question, where were you before you were born, is answered precisely and completely by the physics of conservation, nucleosynthesis, geological cycling, biological chemistry, and quantum field theory. Before your particular pattern assembled itself, your constituent pieces were scattered across this planet and this solar system, cycling through other patterns, doing other things. You were in the soil, you were in the ocean, you were in the atmosphere. You were locked in ancient rock and drifting in comets. You were inside other living things. You were, in the most physically accurate sense, already part of the universe, just not yet organized into this particular temporary, astonishingly complex pattern that thinks and breathes and wonders about its own origins. The wave was always part of the ocean. It just had not yet risen to this height. And what happens when this particular wave, this particular organizational pattern that we call a human being, eventually dissipates? The atoms do not vanish. They return to the larger pool, ready to become part of other patterns. They will feed other organisms. They will cycle through the atmosphere. Some will be swallowed by the oceans. Some will eventually be incorporated into the crust of the earth. Some will drift into space when the sun expands billions of years from now. And billions of years after that, some of those atoms may find themselves inside a new star, forming in what is now empty space, fusing again, building heavier elements, scattered again in a new supernova, cycling through a new planetary system, becoming perhaps part of a new wave of organized complexity that we cannot begin to imagine. You are not a newcomer to this universe. You are the universe, looking at itself through a temporary lens assembled from pieces that have been here since almost the beginning of everything, and that will continue to be here until the last stars burn out and the last structures of matter finally settle into their lowest energy states. The atoms were here before you. They will be here after you. For a brief window of cosmic time, they are arranged in a way that allows this question to be asked. That is not a small thing. That is, if you are willing to follow the physics all the way to its conclusion, one of the most remarkable facts about the nature of existence that a universe governed by these particular laws of physics has ever produced.